I'm Anil Kumar, and in this video we will try to understand how to find general solution for a trigonometric ratio. Now this will also help us to solve trigonometric equations. After all, at the end we'll end up with situations where we have a ratio, and so I hope this video will form a good base for solving trigonometric equations. So we have two examples here. One is sin x equals to 0.2367. The other one is cos x equals to minus 0.4986. Now to find a general solution, we should actually look at the function from a couple of angles. One of them is the cast rule. What I mean to say is we should know in which quadrant the function is positive, in which quadrant the function is negative. Now as far as sin x is concerned, we are looking for a positive value. That means we are looking for, in one full cycle, we are looking for two solutions. One of them has to be in quadrant 1, the other one has to be in quadrant 2. So, and then we know sin x is periodic, so it is a periodic wave, and the period for sin x is 360 degrees or 2 pi radians, is that, depending on what units you use, right? So that means that both the solutions are going to repeat every 360 degrees or 2 pi. And that is how we get general solution. Is that okay? So let's begin by finding the angle x, which is going to give us approximately 0.2367 as the answer. So if sin x is equals to 0.2367, then x is equals to sine inverse of 0.2367. So we can use calculator and find this answer. Shift sine, and we have 0.2367 equals to, it gives us 13.6918. So we get 13.6918. So for the time being, we'll just round them to one decimal place. So we can say approximately it is equals to 13.7 degrees. So that is one of the solutions, as you can see. So whenever you use calculator, you can get only one solution, and most of the time it is recommended to find the related acute angle. So in this case, we found the related acute angle is 13.7. That means this is probably, let us say, that is 13.7 for us, and that is one solution. So we got a solution for quadrant 1. How about this solution? How to get that one? Well, using the properties, we can find that. So from here, we can see that the other solution should be 180 degrees minus 13.7, right? That will give us the solution in quadrant 2. So the other solution, so let me write this as x1 value, one of those values, and x2 values as 180 degrees minus 13.7, okay? So let's use the calculator and say 180 minus 13.7. That gives us, in decimals, 166.3. So the other solution for us is 166.3 degrees. Well, in this video, we are doing them in degrees. You can actually convert your setting to radians and do it in radians in a similar fashion. Now that is this angle. That is to say that the other solution here will be 166.3 degrees. Now the question is how to provide with general solution. As we know that sine wave is periodic, it will repeat after every full cycle. Now one full cycle is 360 degrees, and therefore in general we can say that our answer is, we have two different solutions. So one set of answers will be 13.7 plus n times 360, right? So we could write 360 degrees times n, and the other one will be 166.3 degrees plus 360 degrees times n, where n belongs to integers. So that is how we can write general solution for sin x when x is positive. Now we have another example here. We are talking about now cos x, which has a negative value. So let's look into those solutions now. Now applying the same cost rule as we did earlier, we'll follow exactly same steps, correct? When is cost negative? Cost is negative in quadrant 2 and 3, right? We are given cos x equals to minus 0.4986. So what we will do is first we'll find solution for cos relative angle, which will take positive value, and then we'll find these two angles. So that is the concept. First find related acute angle, which will provide you with actually solution of cos of plus 0.98. That's somewhere here in this quadrant, okay? Quadrant 1. So let's do cos inverse of this. So shift cos inverse of 0.4986. That gives us 60.09. So we get x relative or acute angle, you can say, or sometimes we write alpha is 60.09. So approximately it is, let us say, 60.1 degrees, right? So that is related acute angle. That is XR, related acute angle. We can also sometimes call it by names like alpha or whatever you want to say, or just A, okay, the acute angle. Now once we have found this, then we have to find the solution for cos x equals to negative of 0.4986. So those are two values. One of them is in quadrant 3, the other one is in quadrant 2, right? So these are the two answers. So what we are looking for are principal angles, which should be, this is one principal angle. Let me call this as x1. And how much is this angle? XR, this is XR, right? So this angle is 180 degrees minus 60.1, correct? The other one is this angle, which is how much? So x2, the second angle, will be 180 degrees plus 60.1. Do you see? That is how we'll get our real solution. And these two solutions are in one cycle, right? Let's find out these answers. So it is 180 plus 60.1. That gives us, in decimals, 240.1. The other one is 180 minus 60.1, and that is equal to 119.9 degrees. So these are the solutions in one cycle, correct? Now to provide with general solutions, we know that cos repeats after every 2 pi or 360 degrees, right? So we can write our general solution as, it could be two values for the angle. One is 119.9 degrees plus n times 360 degrees, or it could be 240.1 degree plus n times 360 degrees, right? You can also do this calculation in radians, and then the time period, or I should say the period, will be 2 pi, right, when it is going to repeat. But I hope you understand and appreciate that use your calculator to find related acute angles. So the steps are: find related acute angle, then you have to apply the cost rule to find what are the possible solutions, correct? And then generalize yourself for cost rule to find possible solutions, right? As we did here, and then make it general, as we did. So follow these steps to get these answers for solving any trigonometric equation. I hope that helps. Thank you and all the best.